So continuing to work with similar triangles, there are certain triangles that automatically have a similar, a triangle that is proportional with it. In every problem that we've done so far, we've always had a second triangle to compare it to. And what we're going to find today is there are what's called special right triangles, 45, 45, 90 triangles, and 30, 60, 90 triangles. And what we're going to find is that every single 45, 45, 90 triangle is similar to every other one. And every 30, 60, 90 triangle is similar to every 30, 60, 90 triangle. And so we're going to get our reference triangles, that second triangle that we need to be able to set these up. Now, some of you are going to be able by the end of the lesson to see what the pattern is, but I'm going to teach it to you with proportions because that's how we've been doing proportions. And that's what we've been using is setting up proportions. And these are indeed similar triangles. We just don't typically have that second triangle to look at. But if you know it, then you can use proportions or you can use the pattern. There are certain problems that are more difficult with the pattern, but it is definitely doable. So let's first look and see how these triangles behave. First, you look at this triangle, solve for x and y, leave our answers in simplified radical form. So we're just going to kind of develop some stuff here. I noticed that this is an isosceles triangle. Those two are the same. What that means is then if that one angle is 45 degrees, then this other angle is 45. If those two angles together add to 90, then that means that this third angle is 90. So this is a 45, 45, 90 triangle. I know that x is 6, or excuse me, x is 6. X is 3. If I can get my pen to write, x is 3 because those two sides are the same. And then I can use Pythagorean theorem because I have two of my three sides. I can do a squared plus b squared is equal to c squared. Okay, because y is your hypotenuse. So 3 squared is 9. 9 plus 9 is 18. So we get that y squared is 18. So if I take the square root of both sides, then I get that y is equal to the square root of 18. And I want to simplify that. So remember, different ways you can do this, but you can do 2 and 9. So I'm going to stop at the 9, and the reason is because I noticed that's a perfect square. So I'm going to take that square root of 18 and let it become the square root of 2 and the square root of 9. You might not see that, and you might need to go here and do your 3 and 3 and then find your pairs. So it just depends on what you see and what method you use. The square root of 2 is a decimal that I don't want to use, so I'm going to leave it alone. And the square root of 9 is 3. And so the square root of 18 is 3 root 2. So here's what I want you to see. I see that this side is 3, the other side is 3. The two sides that are across from the two angles that are the same have to be the same. And this side is 3 root 2. Now, look at what they have in common. They all are a factor of 3. So if I go through and divide by 3, divide by 3, and divide by 3, I get this side is 1, this side is 1, and this side is the square root of 2. And what we're going to find is that every 45, 45, 90 triangle can be reduced down to those three numbers. So my sides that are congruent, there are two ways that I can tell that this is a 45, 45. I can give you that the angle is 45, or I can give you that the sides are congruent to each other. And so this is 45, 45. So my reference triangle is going to be 1, 1, and then root 2. Those are going to be the numbers that I'm always going to refer to. You can see their ratio. Two of them have a ratio of 1 to 1. The other sides have a ratio of 1 to root 2. So then let's look at this other triangle. So we have this other triangle. It is an equilateral triangle, which means it is also equiangular, which means all three of these angles are 60. Then that means this angle is split in half. It got split into 30. So what we want to look at, because the other triangle we want to talk about is a 30, 60, 90. So let's use this and let's just find out some more information. You're not going to be asked to reproduce this. I just want to show you that this actually exists. I'm not just making up numbers. So when I drop down that altitude y, it splits that side in half, and all three of these sides are 10, because if it's equilateral, it's equiangular, and vice versa. And so that altitude cuts the side in half, so this side is 5, this side is 10. And then if we do Pythagorean theorem, so we have y squared plus 5 squared is equal to 10 squared. I have y squared plus 25 is equal to 100, or y squared is equal to 75. If I go in and split that, right, take that 75, split it up, then I get 3 and 25. Let's take the square root of both sides. That's going to leave me with 5. I put the wrong number in the wrong place. 5, the square root of 3 and the square root of 25. The square root of 25 is 5, and the square root of 3 is a decimal that we don't want to deal with, so we're going to leave it alone. We're not going to simplify it any further. So that's 5 root 3. So here's what I want you to see. We have 5 root 3, and we have 10. Now what's important about that is that all three are a factor of 5. So if I go through and divide by 5, divide by 5, and divide by 5, 5 over 5 is 1. 5 root 3 over 5 is root 3, and 10 over 5 is 2. Now, notice where the 1 is. The 1 is across from the 30. Okay, so if we go over here, let's create our reference triangle. Here's my 30-degree angle. This is what's called my short leg. Okay, the short leg is always opposite of the 30-degree angle. Remember, we talked about a while back that short sides are across from small angles, long sides are across from large angles. Okay, and so my short leg is across from the 30, and we're going to put the 1 on the short leg. Then notice the root 3. So we had our root 3 right here. It's across from the 60. So this is my 60-degree angle, and so the side that is opposite of that, let me kind of color it, that's called the long leg, or the longer leg. It is the square root of 3. So the longer leg is opposite of the 60-degree angle. Now, you may be looking, okay, but it's 3. But remember, the square root of 3 doesn't have a value of 3. It has a value of 1.73. And so it is next in line. So 30 is the smallest angle, so 1 is the shortest side. 60 is the medium angle, and root 3, or 1.73, is the medium side. And then that leaves 2 to go on the hypotenuse. The hypotenuse is always opposite of the 90-degree angle. So those numbers always go in those locations. The 1 goes across from the 30. The root 3 goes across from the 60, and the 2 goes on the hypotenuse, which is across from the 90. Okay, so keep those two triangles. These two right here, these are our reference triangles. Those are our second triangles, right? We always, with similar triangles, we always had a second triangle. And so you might come down here and you're looking at these two just to give you kind of a reference of what we've got going on. I'm going to put 1, 1, root 2. And if you remember how I would always take these and I would put all my numbers onto one place. So the 4 matches with the 1, the other 4 matches with the other 1, and the x matches with the root 2. So here's what we're doing. The first thing that I'm going to show you is how to set these up with proportions so that you always have a backup. Okay, and so now all you have to do is you set up, and I can tell this is 45, 45 because these sides are the same, which means these angles have to be the same, and you have 90 degrees left. So we set it up. So I want to find x, so I say x over root 2 is equal to 4 over 1. Now you're going to see you don't always have to do the whole cross multiplication, and in fact, usually when you're doing cross multiplication, you multiply and then you divide. In most cases here, you're going to want to divide and then multiply. So you're going to want to divide your 4 over 1 and then multiply by the square root of 2. Okay, or just learn how to kind of see this. If you cross multiply, there's no need to do that x times 1. That's x, and then 4 times root 2. This is probably the hardest one because 4 times root 2, you want to do something with those numbers and get something different, but you can't. So 4 times root 2, we just write it down. 4 times the square root of 2, 4 root 2. It's just like doing 6 times x, and we write 6x. It's the same thing. You can't actually do the math because the 4 is on the outside of the square root and the 2 is underneath, and so you can't do anything with it. And that's the answer. So we have our sides are 4, 4, 4 root 2. Okay, so let's look at B. I can see that B is isosceles, which means this is a 45, 45. Later on, when they're mixed up, you're going to have to be able to tell which triangle did I use. So I match it up with my reference triangle. Anytime you see 45s and 30s and 60s, this is what you do. Match it up with your reference triangles. Okay, now you might notice something here, and I would go ahead and deal with it. Let's go ahead and take care of that 20 root 2 over root 2. Those root 2's cancel out. That just leaves me with 20. It's much prettier. Okay, it doesn't have to be done now. It can be done later, but that makes it much prettier here. X over 1 is equal to 20. Remember, if you cross multiply, there's nothing underneath that 20. There's a 1 that's assumed. So 20 times 1 would be 20. And then we know that x and y are going to be the same values. They both have a 1 on them. So those x and y's are going to be the same. Maybe you don't see that and you go ahead and set it up. Maybe you didn't see that you could reduce that root 2 and root 2. So it might look like this. And so y over 1 is equal to 20 times root 2 over root 2. And then you always want to reduce when you can. So you get y is 20. And so we have 20. And then we have 20, and then we have 20 root 2, right? I simplified it because I had the ratios there, but actually the side length is 20 root 2. So I had 4, 4, 4 root 2. I had 20, 20, 20 root 2. So we see this, we look, we see that problem C is, again, a 45, 45, 90 triangle. So I'm going to add my reference measurements so that I can set up my proportions. I have x over 1 is equal to 20 over root 2. Okay, so that x over 1, remember that the goal is to get the x by itself, so really all we care about is that 20 root 2. So x can be 20 root 2, or remember that can be simplified to 10 root 2. Just a quick reminder, 20 over root 2, when you rationalize it, you multiply by the root that's on the bottom. So you get 20 root 2 over 2. Root 2 times root 2 is 2. Remember, root 2 times root 2 is root 4. The square root of 4 is 2. And then that 20 cancels with that 2. This is what we did the other day, and you get 10 root 2. Okay? Or you quick look at it, right? 20 divided by 2 is 10, and then it's root 2. That's your quick know how to look at it. So 10 is 10 root 2. X is 10 root 2. Y has to be the same thing because it's x over 1 and y over 1. So we'll save ourselves some work. It's also 10 root 2. So it's 10 root 2, 10 root 2, and 20. This is what I called a built-in. The root 2 is supposed to be here, right? That's where we normally have a root 2 and a 45, 45, but it isn't there. Technically what it is it's 10 root 2 root 2. And 10 root 2 root 2 is actually 20. So it's what I would call a built-in. But the root 2 is going to be somewhere. You got to have a root 2 somewhere in there. Okay, let's look at D and E. So D and E, now we're shifting gears. This is a 30, 60, 90 triangle. And so remember that with your 30, 60, 90, we're going to use as our reference numbers 1 and root 3 and 2. Okay, 1 and root 3 and 2. Remember, the 1 goes across from the 30. So I'm going to put my 1 on there first. I like to put my 2 on there next. It goes across. It goes on the hypotenuse. Those two sides are the easiest ones typically to find. And then your root 3 goes across from your 60. So now you have your proportions. I want to solve for x, so I'm going to set that up. X over the square root of 3 is equal to 7 over 1. That's the only other ratio that I have both parts to. So now I do my cross multiplication. There's no sense in multiplying x times 1. That's just x. And then 7 times the square root of 3. I can't multiply the 7 and the 3, so I just write 7 root 3. Again, that's going to be one of the hardest things for you to remember to do. And then we have y. So we have y over 2 is equal to 7 over 1. When you cross multiply that, you get y times 1, which is just y, and 2 times 7, which is 14. So y is 14. So we had 7, we had 14, and we had 7 root 3. Now I'm just going back and writing them there so that you can start to see that there's a pattern that you can follow. With E, 30, 60, 90, we're going to put our 1 across from our 30. We're going to put our root 3 across from our 60. And we're going to put our 2 across from our 90 degrees on our hypotenuse. And then there are our proportions that we're going to set up. So I have x over 1 is equal to, now notice it's 12 root 3 over root 3. Notice those will cancel. I got a root 3 that'll cancel a root 3, one in the numerator, one in the denominator. So that equals to 12. Well, x over 1 is equal to 12, which means x is equal to 12. So this side is 12. This side was 12 root 3 originally, remember? And then y over 2. Let's set it up. Y over 2 is equal to 12, right? If we cross multiply, there's nothing to multiply the y by. And 12 times 2 is 24. And that makes sense. 24 divided by 2 is 12. So this side is 24. Okay, so hopefully you're starting to see a little bit of a pattern. If you don't see it yet, then look for it in a minute. Okay, now I recommend that you turn the video on pause for just a second and work through these next at least 9 problems, and we'll come back and work 10 and 11 and 12 because they're a little more complicated. 1 and 2 are very straightforward. 3 and 4 are a little more complicated. 5 and 6 are straightforward, and then 7, 8, and 9 are a little more complicated. But if you do these with proportions, then you're not going to be affected by what is difficult and the numbers being built in and not looking like normal. So hit pause and try them yourself, or keep listening and we'll go through and work them. So it's 45, 45. We're going to do 1, 1, root 2. Okay, remember your 1 and your 1 go on your congruent legs, and your root 2 goes on your hypotenuse. Then set it up. X over 1 equals, we need the side that we have that we can use. That's 42 over 1. If you cross multiply this, x times 1 is x. 42 times 1 is 42, so we would get that x is 42. And then we need y. Y over root 2 is equal to 42 over 1. Again, do your cross multiplication. Y times 1 is y. 42 times the square root of 2 is simply 42 root 2. And so in the end, we end up with x is 42. So I have 42, 42, and then 42 root 2 is the length of y. Remember the 1, and the root 2 that you added to the problem? Those are just our reference triangle. They don't actually have anything to do with how long the sides are. So 2, we have 1, 1 root 2. So we have x over 1 is equal to 15 root 2 over root 2. I'm going to go ahead and take care of that while I can, make it easy for myself. 1 times 15 is 15. Y over 1 is equal to 15 again. So we have that y is 15. So that is 15, 15, 15 root 2. If we look at 3, again, we have our 1, and our root 2. So we have x over 1 is equal to 24 over root 2. Now, y'all, you can cross multiply this, but it doesn't do a whole lot of good, right? Because then you're going to end up dividing